I want to share my screen. Now let me uh, start from the orthogonal exception for the hill road. I think I have started. Now this is the hill road. Uh, in the hill road, the cross slope of the ground along the cross section direction, there will be the cross slope of the ground. That cross slope of the ground is also called the transverse slope, cross slope or transverse slope. If in the examination, if you are asked to do rate analysis, do ortho calculation for the road, giving the cross slope, this transverse slope, then that problem is for the hill road. Without stating the road type of the road, you may be given the cross slope. Hello,
के भाको क्वेश्चन नंबर 1 में हो गया इसको
Vasco.
यो हिल रोड को
Hill road question number one पुगिसक्यो. This is the question, the quantity of Arthur for the given portion of the road with the following data. This is provided for the hill road. Now you have to check whether these data are for the fully cutting case or fully filling case or the partial cases. Okay. For this you have to multiply the depth with the cross slope. If the value is greater than or equal to half width of the road, then that will be in fully case. If the depth is given in filling, that will be fully filling. If the depth is given in cutting, that will be fully cutting. If multiplying the depth with the cross slope and the value is less than half width of the road, that is b by 2, small b, then that case that will be in the that road will be in the partial case of cutting and filling. In that way you can separate them. Okay, now using the graphical solution, I have done this numerical. The you can look at the change 0 meter, 50, 100, 150, 200, 250, and 300. These are the channels of the changes of the given road section. And from the first channel 00, the depth is 1.20. This is multiplied by 10. This depth is a filling depth because it is positive here. And other depth 2.30 and the minus 1.30 are the negative sign depth here. So it is the cutting portion depth. Okay. And this is depth is filling. If you multiply this depth with its respective cross slope, I will get the value of 12.50. Okay, 10 into 1.25, 12.50. This value 12.50 value is greater than half width of the road, that is total width of the road is 10 meter, 5 meter. Okay, 12.5 is greater than 5 meter. That's why this road is in fully case. And the depth is given as the filling. The case will be fully filling. For the second 50 meter, 6 into 0.5, 3 meter, which is less than the half width of the road, 5 meter. So this portion of road will be in the partial case, and the depth is given as filling depth. So you have to make the figure of the partial case having depth of filling. Okay, you have to use in this way. Now for the 100 meter, 90 into 796, that's 6.3 meter. Okay, 63, 6.3 meter, which is greater than the 5 meter width of the road. So it is also in fully filling. Now for the 150 meter, 2.3 is multiplied by 6, it will be 13.80 meter. 13.80 meter, which is also greater than the 5 meter half width of the road. That's why and the sign is negative here. A cutting depth is given here, so this is fully cutting case. And for the 200 meter, it is 0 into 4, it is 0, which is less than half width of the road. This is the partial case having depth is equal to 0. Okay. Now 250 meter, 9 into 1, It is the 9 meter greater than 5 meter. It is fully filling case because the depth is given as 1 meter of filling. Now for the 300 meter, minus 1.3, this is the cutting depth. 13 into 10, it will be 13 meter. 1.3 into 10, it will be 13 meter greater than 5 meter. Okay, this is also the fully case. The depth is given as the cutting depth. So it is the fully cutting case. Now look at these things here. From chain is 100 to 150 meter. The filling portion is filling section is changed to the cutting section from the 100 meter to 150 meter. So there must be zero change in between it, 100 meter and 150 meter. Similarly, from 250 meter and the 300 meter, there is also change of the sections from the filling to the cutting. 1 meter is height is filling, 1.3 meter height is of cutting. That's why from channel 250 to 300 meter, there must be zero depth change in between it during the changing of changes from the section from the filling to the cutting. You must know that. So we have to find the changes of that respected zero depth of in between 250 and 300 meter and in between 100 meter and 150 meter from the given table. We have to provide that. For calculating the change of zero depth, you can use the similar triangle of the rule by as in the plain road. Okay, you can do in this way. Now using the graphical solution, I have done the numerical problem for Chinese meter. Look at the Chinese meter. For the Chinese meter, the depth DF depth is given for the DF. So you have to provide the. So you must fully case is there fully filling banking case or filling case. You have to draw this type of figure. You have to draw first this fully filling figure. Okay, this fully filling figure d is equal to I think that is 1.2 meter or 1.25 meter. Okay, and the value of d is equal to 1.5 meter here. SF is equal to 2:1. The total width of the road is 10 meter. Half width will be 5 meter here. You have to put the value. The R value is given as 10:1, I think, for the first case. Okay, 10:1. The R value will be 10:1. You put these values for this figure, and the figure becomes this type of figure can be here. The portion of the road that will be in fully banking is figure shown by the figure of this yellow line. Okay, this red line gives the figure of the fully banking, fully filling case. D is equal to 1/5, side slope 1/5 is to 1, and half width of the road is 5 meter. Another half width is 5 meter. Total width of the road is 10 meter. Now, from this section, we have to calculate this. We have the sectional area of this filling portion because it is not the geometrical figure, so we cannot calculate the quantity of earth using this geometric figure as of the trapezoid shape because this is not the plain road. This inclination of the this ground surface. This is the inclination of the surface, which is uh, 10:1. Cross slope is provided, but in the hill road, plain road there is no cross slope. Okay, for this after drawing the fully section and you prolong this JB line, prolong this JB line to point C, which touches the cross slope at point C. Again prolong this JB line up to point A. From A draw the perpendicular up to the point D. Okay, and you get this figure of the big triangle as ACD and the small triangle will be ADJ and BEC. Okay. Now from A to D, let the value of this portion particle perpendicular portion Vx, and from similarly from point E to have from the line baseline BC draw the perpendicular so that to the point E and this distance is equal to y. Put the value of this vertical portion of this perpendicular be y. Now due to this 10:1 slope, due to this 10:1 slope, if for the triangle ABC, ACD, If the perpendicular is x and the slope is 10 is to 1, then from A to C the horizontal distance must be 10 into x. Okay, the slope is 10 and the vertical height is x. So the from the distance A to C, the horizontal distance will be 10x. Okay. Now for the triangle, for the second triangle having the perpendicular height of 1.25 up to the point C, this triangle, half triangle, this triangle is the right side of the center line, the bigger triangle, and this has the perpendicular of 1.25. The horizontal distance from the center line of the road to the point C will be 1.25 into 10. 1.25 into 10, that value will be 12.50 here. I have kept this value as 12.50. Okay, this value will be 10 into 1.25. I have given the directly this value here. Okay, into 1.50, you will get the value of 12.5 here. Okay, which are the figure, and I have given the values. Now for the x, for the vertical height AD as x, for the triangle AJD, for the triangle AJD, the slope is 1.5 is to 1. The slope is 1.5 is to 1. Then the horizontal distance AJ will be 1.5x. Okay, because this perpendicular is x and the slope is 1.5, the horizontal distance will be 1.5x. Now for the triangle BEC, for the triangle BEC, the perpendicular height is y and the slope is 1.5 is to 1. So that from the perpendicular towards the left hand side to B, the horizontal distance will be 1.5y. Okay, 1.5y. Similarly, for this triangle, the perpendicular is y, and the towards the left hand, right hand side of this, the distance will be 10y, because the slope for this right hand side triangle of perpendicular of y distance, this has the slope of 10 is to 1 here. So y into 10, this value will be 10y. Okay, you can mention these values according to the slope of the triangle. Okay, and you will get the value horizontal distance accordingly. Now from the full triangle, ACD, you can the horizontal distance 10x. The horizontal 10x will be 1.5x plus 5 meter plus 12.50 meter. Okay, and the horizontal distance 10x will become to, you can see at the top, from A to C, this is 10x, the value is 1.5x plus 5 meter plus, and from the center line to the point x, this is 12.50. Okay, 12.50 plus 5 meter plus 1.5x, this value will be the 10x. The 10x is equal to 1.5x plus 5 plus 12.50, and on solving this, the value of x will be 2.059 meter. The value of x will be 2.059 meter. Now for the next, for the 12.50 meter horizontal distance, for the 12.50 meter horizontal distance, total length will be 5 meter plus 1.5y plus 10y. Okay, for 12.5 meter, total length will be 10y plus 1.5y plus 5 meter. This is the same distance of 12.50 meter. So 5 plus 1.5y plus 10y is equal to 12.50 meter. Here the only the variable is 10 here, y here. So the y value will be 0.65 meter. Using this triangular half length, half width of the road up to the point C, on the right hand side, will be 12.50, that is equal to 5 plus 1.5y plus 10y. From the figure here, you can find the value of x and y respectively using this. Now for the section area JBED, for the section area JBED, we have to have this area. This area will be area of the triangle ACD minus area of triangle ADJ and area of triangle BEC. Okay, from the big triangle, if you deduct the area of AJD and area of BEC, then you can find the area of JB ED triangle of the trapezoidal shape. Okay, we use this formula. We know the value of x, we know the value of y, and we know the total base length as well as the perpendicular of the triangle. So that the area of the filling portion, this is equal to bigger triangle minus the smaller two triangles. Okay, minus the smaller two triangles. So we have the area of this filling portion would be half 10x into x. Okay, half 10x into x, area of the bigger triangle, minus half x into 1.5x for the triangle ADJ, and the half 11.5y into y for the BEC triangle, because base will be 10y plus 1.5y, so the total base will be 11.5y. Okay, now this you can use this formula to find the to calculate we have the filling portion of this red area, red sectional area will be this, and put the value of the x and y in this area, you will get the area of filling as 15.59 square meter. Because it is a fully case, so there is no area of cutting, so area of cutting will be 0. Okay, this is the first change where it is a fully filling case, so that the figure is drawn, and to find the area of this figure we have done other things here, by prolonging the line B to C, prolonging the line J to A, and drawing the perpendicular bisect up to the point E, and up to the point D from A, and from the line base of the line BC, and from base of the line BG. According to this figure, we have calculated the cross section area of this section. Okay, and this is for the geometry change. So for the change of 50 meter, for this I have done the same procedure for calculating the area of the section of the channel 50 meter. This channel is the partial case, because the depth and the cross slope after multiplying the value is less than the half width of the road. So this is the partial case channel, and I have drawn the partial case channel here. The R is 6, R value is 6, and the depth value is depth of filling here 0.50. You have to draw this this figure number 3. Depth is given as depth of filling, and R is given as 6:1, depth of filling as 0.50 meter. Okay, total width of the road is 10 meter, half width of the road will be 5 meter, 5 meter, and the two types of area will be seen for that case, area of cutting as well as the area of filling, but area of filling is greater than the area of cutting for the providing the depth of the filling case as the partial case. Okay, you have to draw this type of figure. Now I have drawn the figure here. For this case, I have drawn this figure here. Okay, this yellow figure is of the partial case figure having the depth is equal to 0.50 filling. So the filling area is larger here than the cutting area. This portion of the area is below the area. The red line surrounded area below the green line will be the area of cutting, and above the green line, the red line covered area will be the area of filling. Okay, for this now I have prolonged this line up to this point, the to end of the slope of the filling, and from the formation level, and this vertical height is considered as x. Similarly, I have prolonged the base of the cutting portion to the towards the upper two of the cutting slope, and this value, and that particular perpendicular bisect perpendicular is drawn, that value is y. Okay, now I have putting the side slope value for the respective cutting and the filling as 1:1 and 1.5:1 in the figure. Now the cross slope is 6:1. Okay, now the half width of the road from this portion half width of the road from the center of the road. Center of the road, this is the half width of the road. This is the portion, and this is 5 meter. Okay, and half width. This is 0.50 here. This is 0.50. The slope is of 10 is to 1, 6 is to 1. So this value must be up to the center point of the road towards the right hand side up to the ground cross slope. The horizontal distance must be 0.50 into this slope is 6 into 0.50, 3 meter. This 3 meter is not sufficient for the half portion of the road in filling. So 2 meter have to be excavated into the cutting portion to provide the total width of 5 meter from the center line towards the right hand side here. And this portion may be cut accordingly. So this is 5 meter and this is 3 meter here. Okay. Now using this vertical as x, the slope is 6 is to 1 here, 6 is to 1 for the bigger triangle up to the this left hand side, and the x, this is x value, this is 6 value. So the from the horizontal distance of the this side of the x perpendicular base towards the up to the intersection of the formation level and the ground level, and this height would be 6x. Okay, because slope is 6 and the vertical height is x, this value will be 6x. Now for the y, look at the small triangle here, this value is y and this slope is 6. So from this from the ground level towards the base of the line, right side of the triangle, this will be 2 y into the slope is 6, this will be 6y. For the slope of this cutting portion 1 is to 1, the horizontal distance for this small triangle base will be 1 into y, and this value will be y. Okay. Now for the small triangle here, the 6y is equal to 2 plus y. Okay. 6y is equal to 2 plus y. Y value will be 0.40 here. Now for the 6x, the value will be 1.5x plus 5 plus 3. Okay. For 6x is equal to 1.5x 5 plus 3, you will get the value of x is equal to 1.78. After knowing the value of x as 1.78 and y as 0.40 meter, use the similar way to find the area of the filling as the area of this red triangle. Okay, left hand side red triangle above the ground level. This will be the area filling will be bigger triangle minus this small triangle of a perpendicular having perpendicular distance of x. Okay, so that area filling will be half 6x into x minus half 1.5 into x into x. Okay, half 1.5 into x into x. You will get the value of half x into 6x. This is the value of 6x. Okay, this must be if this is x, this will be 6x. 6x into x uh, in half into 6x into x gives the bigger triangle minus the small triangle half x into 1.5x. You will get the area filling, and the area filling will be 7.13 square meter. Put the value of x for this. Okay. Similar, the area of cutting will be this cutting area is a red portion triangular area. This area is a bigger triangular area of the right hand side portion minus this small triangle of having the perpendicular of y and the base of y. You will get the area of cutting half 6y into y minus half y into y. Okay, you will get the value of 4.5 y square. Putting the value of y in this equation, in this case, you will get the value of area of cutting. Okay, this is the partial case, so that the both the area is here. Area of filling is more than the area of cutting. Okay, this is the case for the second 50-meter channel. Now for the 100-meter channel, 100 meter 9 the 63 6.3, which is greater than the 5 meter. This is the fully case. This is the similar of the channel 0 meter. Only the value will be differ. and the cross slope is different, 7:1. Instead of 10:1, put the value of 7:1. Further that, instead of 1.25, put the value of 0.90. Okay, and you will get the value of this value will be this triangle. The shape of the triangle area is same and shape of the triangle also same, but the only value is differ. Now, for change 100 meter, this is the fully case, and because df is equal to 0.90, r is equal to 7:1, so it is fully case, because if you multiply 7 into 0.9, 6.3, that is greater than the half width of the road, 5 meter. Now, this yellow red line figure is the required area filling section. Okay, for this now you have done this in the similar way, and depth is 0.90. This slope is 7. So the horizontal distance from the center of the road to the ground line, and this is the ground line. Green line is the ground line. This green line. Okay, this up to this green line, the center distance will be 0.90 into 7, which gives the value of 6.3 meter. Okay. Now for the x value of this, the horizontal distance from this end point to the ground or slope, this horizontal distance will be x into 7, which gives the value of 7x. Okay. For the x of the slope of this figure, this slope is 1.5:1 for the cutting, 1.5:1. Okay. So this value is x. For this triangle, the slope is 1.5. The horizontal distance from this to this will be 1.5x. Okay, you can put in this way. Now for the 6.30 meter, the total length will be this is total is 10, and this portion will have the length of this portion is 5 meter, and the remaining this portion also is the 5 meter. Okay. The remaining this 5 meter, total is 10 meter, remaining this portion will be 5 meter. Now from the center line to the ground line, the horizontal distance is 6.30 meter. This 6.3 will be 5 plus 1.5y plus 7y equals to 6y. Okay, 6.3 will be 5 plus 7y plus 1.5y, 8.5y, therefore y is equal to 0.15 meter. 5 plus 8.5y, 5, this is 5, and 1.5y plus y, and this is 8.5y. 8.5y plus 5 is equal to 6.3. The y will be 0.15 meter. Okay, for this. Now for 7x, total length will be 1.5x plus 5 plus 6.3. Okay, for 7x, this is 1.5x, and this is 5 plus from center to the end of the point, this is 6.3. 6.3 plus 5 plus 1.5. This will be the 7x, 1.5x plus 5 plus 6.3. You will get the value of 7x. X is equal to 2.06 meter. Now area of this filling portion will be half 7x into x minus half x into 1.5x minus half 8.5y into y. Okay, you will get the area of this red trapezoid section, irregular trapezoid section. Okay, and the area will be 11.57 meter after putting the value of the x and y respectively in this aerial formula. Now from channel, look at the figure here. From channel 100 to 150 meter, we have done up to the 100 meter channel. Now from channel 100 to 150 meter, the section is changed from the filling to the cutting. So there must be zero change in between these two sections. Okay, the zero change is calculated in this way. Now draw the perpendicular and draw the horizontal line from channel 100 to 150 meter. The depth is changed from the filling to the cutting. The filling depth is upper part depth as from the baseline. This is the baseline to the baseline of a suitable any length, and provide the change of the initial point as 100 meter and the change of the final point as 150 meter. This is in between 100 and 150 meter. That's why from the point initial point the perpendicular as 0.90, and from the end of this line draw the perpendicular of 2.30. Okay, and join the tip of these lines by the inclined line, this blue line. The intersection point of the black and the blue line gives the position of the d is equal to 0 depth. Okay, this is the position of 0 depth. D is equal to 0. Okay, d is equal to 0 for this point. For this point, d is equal to, for this point d is equal to 0. You can see here. Okay, this is the d is equal to 0. Now let the this be x up to this intersection point, and this distance is x, and the remaining distance would be, total distance is 150 minus 100. You will get the total distance of the 50 meter. So the remaining base width of the bigger triangle will be 50 minus x. Okay, this 50 minus x. Now use the similar triangle property. Then x will be 0.90 into 50 divided by 0.90 plus 2.3. You will get the value of 14.06 meter. That is x is 14.06 meter. The change of d is equal to 0 will be 100 plus 14.06. You will get the value of 114.06 meter. Similarly, you can see here that from the question, all the chainage, all the depth has the certain cross slope here. Or the chainage and all the depth have the certain cross slope here. If you find the chainage of 0 depth, the depth is known and the chainage is known, but the cross slope cannot be known. So there is no cross slope for that position. For d is equal to 0, we need the cross slope also. That cross slope is worked out by considering the cross slope of the preceding section as well as the succeeding section. The preceding section is 7 and the succeeding section is 6 cross slope. With the help of this cross slope, the mean harmonic cross slope of the 0 depth change is calculated. The 0 depth change is 114.06 meter. Okay, but the cross slope is calculated by using the mean harmonic cross slope, that is calculated by using the formula 2 r1 r2 divided by r1 plus r2. Okay, you can calculate the mean harmonic cross slope for the change of 114.06 meter. The mean harmonic cross slope will be, the mean harmonic cross slope for this change is calculated as 2 r1 r2 divided by r1 plus r2. This is the r1 is the preceding RL, and R2 is the succeeding RL. You put this value in this equation. 2 into 7 into 6 divided by 7.7 plus 6 will give the value of 6.46 meter. 6.46, R value is 6.46. This is calculated. R value is considered as the RM, and this is the mean harmonic cross slope, which is equal to 6.50 meters. Say, because from this figure you can see that from the table, before this section, before the d is equal to 0 meter section, this r1 value will be 7 and r2 value will be 6. Okay, put this value in this equation. You will get the harmonic slope as 6.5:1. Okay, and using this slope, d is equal to 0, this slope is 6.5 multiplied by 0 into 6.0 value, that is less than the half width of the road. So this is the partial case, having depth is equal to 0. So for the channel 114.06 meter, d is equal to 0, rm is equal to rm is to 1 is equal to 6.5:1. So it is the partial case. Now make the figure with respect to d is equal to 0. If this is d is 0, there is no upward or downward depth in this channel. So from this point, draw the 5 meter towards the right hand side, and draw 5 meter towards the left hand side, and make the slope for the, this is slope for the this slope is for cutting slope, cutting portion. So the slope is of 1.5:1, and this slope is for the filling slope, and that is at the 1.5:1. The equation is this. Now prolong the line towards the edge of the this slope portion, so that we can draw the perpendicular of x value from here. And similarly, you have to draw the perpendicular up to the upper two of the this cutting portion from the baseline as y, and for this draw the line distance and draw the perpendicular here. Now according to the y value, the slope is 1:1, so this small base of the triangle of this small triangle will be y, okay, and this is 5. Similarly, this for the cutting portion, this portion is x, the slope is 1.5, so this value is 1.5x. For this triangle also, for the slope of 6.5:1, and the x value, and from this into the intersection point of the base and the cross slope, will have the horizontal distance of 6.5 meter. And for y, and this slope is 6.5:1, then the horizontal distance is equal to 6.5 y here. Okay, from this you can calculate the respected x and y. 6.5x is equal to 1.5x plus 5, the x value will be 1 meter. Similarly, 6.5y is equal to y plus 5, this will be y is equal to 0.91 meter. Now put the find this area of this portion is area of filling, this portion is area of cutting. Okay, let us provide this is the area of cutting portion, this is the area of cutting portion, and this blue has portion will be the area of cutting portion. Okay, and the white portion of the triangle left hand side will be the area of filling. This is area of cutting. This area is calculated here. Okay. This area of cutting will be bigger triangle of the cutting section minus the smaller triangle. You will get the value of the triangle of this red line and green line triangle. Will area of cutting will be calculated in this way as the 2.28 square meter. Similarly, for the area of filling, this bigger triangle minus the small triangle along the filling side, if you deduct this, then this red line covered area will be of the filling section will be the required area, which is half 6.5x into x minus half 1.5x into x. You will get the area of this triangle. Okay, and the area of triangle will be 2.50 square meter. So the partial case area filling is 2.50 square meter, for the area of cutting 2.28 square meter. Now for chain is 150 meter. Similarly, for chain is 150 meter, there is cutting depth, and if you multiply this, there is a fully cutting case. Okay, the R value is 6, depth of cutting is equal to 2.5, chain is 150, and the make the for the chain is 150 meter, 150 meter chain is the section is of fully cutting. Okay, this red area is the fully cutting area. Okay, depth is 2.30, side slope of cutting is 1:1, draw the perpendicular line x, and this value is x, and up to from x to the this horizontal ground color slope, the total horizontal distance will be x into 6, which gives the 6x value. For the 2.30 meter depth from this point to the green line, the horizontal distance will be 2.3 into 6. This value will be 13.8. Okay, 2.3 into 6, this will be 13.8 from the center line to the green line. Okay, now for the slope of 1:1 and the vertical height of y, and the value, this value will be y, and for the slope of x 1:1, this value will be x. Okay, this small portion will be x. This small portion will be x. Now look at the figure. From the center line towards the green line. Okay, from the center line towards the green line, total distance is 13.8. Okay, and the 13.8 is equal to this is 5 plus y plus 6y. This is 5 This is y, and this vertical height is also y into this slope, this becomes 6y. 6y plus small y, y plus 5 is equal to 13. 13.8 is equal to 5 plus y plus 6y. Y value will be 1.26. For getting the value of x, this 6x. 6x is equal to half portion of up to from the green line to the half portion center line distance is 13.8 plus 5 plus x. And this will give the value of 6x will be 13.8 plus 5 plus x, which gives the value of 3.76. Okay, you can calculate in this way. Now the area of the cutting will be the bigger triangle minus the two smaller triangles. Okay, right hand side and the left hand side. So triangle should be derived from the bigger triangle. You will get the area of the red zone. This is the area of cutting. Now area of cutting will be half 6x into x, half 6x into x, a bigger triangle, minus half x into x, this is smaller triangle, minus half y into 7y. This is 6y, this is y, which gives the 7y, y into 7y. You will get the value of area of cutting is equal to half 6x into x minus half y into 7y minus half x into x. This value gives the value of area of cutting of 29.79 square meter. Now it is fully cutting, so the area of filling will be 0. For similarly, for the channel is 200 meter. Before this 200 meter, the depth is 0 here. Depth is 0 depth. So it is not the cutting case, or it is not in the filling case. It is in between it. So 0 depth is already exist in channel 200 meter. So we don't need to find the 0 depth channel here. So this is the 0 depth channel. So this is the partial case, and draw the figure for the partial case of this channel having the cross slope of O is to 1. Okay, for 200 meter channel the cross slope is of O is to 1. Now for the 200 meter channel depth is 0 and the cross slope is 4 is to 1, and so partial case, and you can use the same figure 5 here. Why? This is 1.5 here according to this side slope. According to the side slope, this value is y. For this y, if the this cross slope is 4 is to 1, cross slope is provided as 4 is to 1. Slope is 4 is to 1, 4 is to 1, and that's why y and this horizontal distance will be 4y according to this slope. This value is x, this value slope is 4 is to 1, so this distance will be 4x. And find this is the cutting portion. Right hand side is the cutting portion and left hand side will be the filling portion. This is the hatch portion of this triangle will be the cutting portion, and another hatch portion is this. Look at the figure. This hatch portion is the cutting area, and this the area surrounded by the red lines of the left hand side triangle is the filling area. So after knowing the value of x and y in the similar way, you can calculate the area filling as 5 square meter and the area of cutting as 4.18 square meter. Now this is for the channel 200 meter. Now go to the channel for the 250 meter. For the 250 meter channel, the depth of area filling is given here, and the cross slope of 9 into 1 9 meter greater than 5 meter. This is the fully filling case. So draw the figure of fully filling case for the 250 meter channel. Okay, draw the fully figure for the 250 meter channel. This red line zone is the fully filling area, and you can prolong the line up to the green line. You can prolong the line up to the through of the this filling slope, and draw the perpendicular for the both the cases, and the x is this, let this particular distance be x, and for this small triangle the height will be y, and accordingly the slope 9:1. The right side base will be 9y, and the left side base will be 1.5y, because this is the slope of the filling, so 1.5y. If this perpendicular this horizontal depth from the center line is 1, and this is the slope of 9:1, then the horizontal distance from center line to the green line will be 9 meter. Okay, similarly for this is x, the slope is 9:1, so the horizontal distance from this to end of the filling slope left hand side to the towards the intersection point of the formation level to prolong up to the green line will be 9x. Okay, and in this way you can calculate for this x, for the slope of 1.5:1, this horizontal distance will be 1.5x. Now the half width of the road is 5 meter, 5 meter here, and so the 9 meter will be 5 plus 9 5 1 10.yy. 9 meter will be 5 plus 10.5y, because 9 plus 1.5y will be 10.5y, plus 5 will be equal to 9. Okay, similarly 9x will be 5x, 1.5x plus x plus 9, you will get the value of 9x. 9x will be 9 plus 5 plus 1.5x, and solve the value for the x and y. Now 9x will be 1.5x plus 5 plus 9, 9 will be 5 plus 1.5y plus 9y, which gives the value of y as 0.38 and the x as 1.87 meter. Now area filling is this red zone area, bigger triangle area minus this small triangle area minus the left hand side, right hand side is small triangle area, you will get the area of the filling. Okay, the area filling will be this value. This value will be the area filling. 12.36 square meter will be the area of filling. Now from again look at the chainage here. From chainage 250 to 300 meter, again there is a negative sign here. So the chainage section is from filling to the cutting section. From chainage 250 meter there is filling section, whereas channel 300 meter there is cutting section. So that in between 200 and 300 meter there must be depth for the zero depth. Okay, to calculate the zero depth we use the same rule of the similar triangle. The horizontal distance is 50 meter, and 1 meter of filling and 1.5 meter cutting down, and provide the join the tip of the exposed surface of the drawn lines, and you will get the double triangle and find the value of chainage. And the mean harmonic slope is calculated as 2 into 9 into 10 divided by 9 plus 10. Okay, I will get the value of mean harmonic slope for that zero depth chainage. Now, and that is for calculating the zero depth chainage, chainage of the zero depth 250 meter and 300 meter in between, and the vertical line as 1 meter for the filling and 1.30 meter for the cutting. Join this line, you will get the double triangle, and do calculation for getting the chainage. Okay, and the 1.0 divided by x is equal to 1.3 divided by 50 minus x. You will get the value of x as 1 into 50 divided by 1 plus 1.3. You will get the value of x as 21.74 meter. The chainage of this d is equal to 0 will be 250 plus 21.74. You will get this chainage d is equal to 0 chainage will be 271.74 meter. Okay. After knowing this, the chainage we need the mean harmonic cross slope here. The mean harmonic cross slope will be Rm. Rm is equal to 2 times 9 into 10 divided by 9 plus 10, because the for this the Rm is R for the this section is, for this section R is equal to R1 is equal to R1 is equal to 9. Okay, for this section R2 is equal to 10. Okay, that's why mean harmonic cross slope for this section, the RM is calculated. RM is calculated for the zero depth change. This RM is RM is calculated for the zero depth change. Okay, D is equal to 0 here. Insert this value or this value, D is equal to 0. This value equal to 0. Now for this value D is equal to 0, R1 is equal to harmonic slope, cross slope of the section 250. R2 is the cross slope of the section 300 meter. RM is the cross slope of the zero depth section. Okay, that RM is calculated by using this formula 2 R1 R2 divided by R1 plus R2. Okay, this formula is used here, and the value of RM will be 9.47 meter. You can take this as 9.50 meters, say 9.50, say the slope of this cross slope of this D is equal to 0 will be 9.50 is to 1. Okay, now depth is given for this slope cross 271.74 meter channel will be 0. Now draw the section as D is equal to 0 there, as in the previous case, and put the values of all the values. D is equal to 0 and RM as 9.5 is to 1. Okay, and if this is X, then up to this line, this is the green line is the this is the cross slope line, and this horizontal distance will be X into 9.5 X. This for the second triangle, the horizontal distance will be 9.5 Y, because this is Y, this slope is 9.5 Y. For the slope of 1:1 cutting slope, this value will be Y. For the slope of the filling slope, 1.5:1, this value will be 1.5x. 9.5x will be 1.5x plus 5. 9.5 is equal to Y plus 5. Okay, you will get the value of X and Y using these two equations. You can find the value of X and Y. After finding the value of X and Y, area of the filling will be area of this bigger triangle minus area of this small triangle of the filling section. Area of cutting will be area of bigger triangle minus area of the small triangle of this cutting section. Okay, around the cutting side and the filling side, you will get the value of area of filling as 1.59 square meter and the area of cutting as 1.48 square meter. Okay, now for chainage, last chainage, this is the 130 meter chainage, 330 meter, 300, 350 meter chainage, 300 meter chainage. The cutting depth is provided here 1.3 into 10, 13 meter, which is greater than the 5 meter opposite of the road. So this is fully cutting, because depth is given as cutting depth. It is fully case, so the fully cutting case. Draw the fully cutting case figure for the chainage 300 meter. This is the fully cutting case figure for the chain 300 meter. D is equal to 1.3. R is equal to 10:1 provided for this section. Draw the vertical line Y. According to slope 1:1, this value is Y. According to slope 10:1, the value will be 10Y. Okay. For the X, this value is considered as X. This is slope as 1:1. This will be X. This for this X, for the left hand side, this will be 10x. Okay, because the slope is 10:1, this slope is 1:1. Don't confuse, this slope is 1:1, so this x into 1, this value is x. This slope is 10:1, this slope also 10:1. Okay, slope is here. If this vertical height is x, then the horizontal of this small triangle will be 1 into x. If this height is x, and according to the slope of this 10:1 line, and this length will be 10x. Okay, You can do in this way. Now for the 13 meter length, this is 5 plus x plus 10x. 5 plus x plus 10x will be 13 meter, and for the 10y, this distance will be 13 plus 5 plus y. 13 plus 5 plus y up to center line 13 meter, and center to this slope portion 5 meter, and the remaining portion is y meter. That's why 10y is equal to 13 plus 5 plus y is equal to 2 meter, and the x is equal to 0.73 meter. The area of this cutting portion will be a bigger triangle minus two triangles, small triangles, this having the base of 11x and the y. Okay, you can calculate the area filling 0 because it is fully cutting case. We have the only the area of cutting here. No area filling is required. We need the area of this section. Okay, we need the area of this section. In the area of this section. We don't need another section. We need the area of this section. This is the area of cutting section. Okay. You can calculate the cutting area of 15.07 square meter. Now we have calculated all the areas of the respected sections, whether they are of zero depth, whether they are of the changing section, as well as other given sections according to the section is either in filling, maybe either in fully case, maybe either in partial case. So that according to that we draw the figure, and using the figure we calculated the area of each section. Okay, now to find the volume quantity of earthwork, now make the table like this. Okay, make the table like this. The serial number 1 2 3 4 5 7 8 9 here chain is 0 meter, 50 meter, 100 meter. After 100 meter 114.06 meter because D is 0 change here, and 150 meter, 200 meter, 250 meter, and 271.74 meter. D is equal to 0 change here, and the 300 meter. Now the section area is calculated for the first section. For the first section 0 meter fully filling, so there is no cutting depth. Okay, for the first section of 50 meter 0 meter, and there is no cutting, so area filling is 15.59 square meter, area cutting is 0. Putting this value for the section 50 meter, area filling as 7.13 and the area cutting as 0.40 square meter. Okay, in this way I have putting the data of the respective channel. For the first 0 meter channel, it is fully case, so there is no cutting area, only the filling area is there. We have calculated for the channel 0 meter. This is the fully case. Okay, fully filling. For the 50 meter channel, this is partial case. That's why section area of the cutting as well as the filling is here. Okay, for the 100 meter channel, it is fully case, so the only fully filling, so the section area of filling is here. Section area of cutting is 0. Okay, for the 114.06, this is the D is equal to 0 channel, it is partial case, so the cutting area of 2.28 and the filling area is 2.50 is here. Now for the 150 meter channel, this is the fully case of the cutting, so the cutting area is 29.79 meter area. Because this is fully case of cutting, there is no the area of the filling, area filling will be 0. Okay, for 200 meter, this is also the fully, this is also the partial case, having the cutting area depth of 4.18 meter, cutting area of 4.18 meter square, and the filling area of 5 meter square. For 250 meter channel, it is a fully filling case, so the cutting area is 0, filling area is 12.36. For the 271.74 meter, D is equal to 0 depth here, so the partial case, and the area of cutting will be 1.48 and the area of filling will be 1.79. For the 300 meter channel, it is fully cutting case, so the area of cutting is 15.07 meter. So this is fully cutting, so area filling will be 0. Now mean section area, for cutting 0 and 0.40, the mean area will be 0.20. For filling 15.59 plus 7.13, mean will be 11.36. For 0.40 and 0.20, the mean will be 0.20. Okay, for 7.13 and 11.57, mean area will be 9.35. 0.0 and 2.28 mean area is equal to 1.14. For this 11.57 plus 2.50 divided by 2, you will get the value of 7.04. In this way, the mean area of the respective cutting and the filling is calculated. Now, distance between the length between the section will be 50 minus 0, 50. 100 minus 50, 50. 114.06 minus 100, 14.06. 150 minus 114.06, 35.94. 200 minus 150, 50. 250 minus 50, 50. 271.74 minus 250, 21.74. 300 minus 271.74, you get the value of 28.26. Now multiply cutting area, mean area with the length, multiply filling mean area with the length, and put them in the respective column of the for the volume of quantity of ortho calculated for cutting and filling respectively. Okay. Now 50 into 0.20, 10 square meter, 10 meter cube. 11.36 into 50, 568 cubic meter. Now 20 into 0.2 into 50, 10. 9.35 into 50, 467.5. 1.14 into 14.06, 16.03. 7.04 into 14.06, 98.9. In this way, calculate all the quantities of the respective rows of cutting and the filling, and add all of them as a total as 1816.59 and 1911.11 cubic meter. This is the volume of earth for cutting and banking is worked out to be 1816.59 and 1911.11 cubic meter respectively. You can calculate all the quantity of earth for the hill road in this way. Okay. Hello. Hello. हेलो बुझ्यौ गरेको
बुझियो सर
ल जम्मै तिमीहरूले प्र्याक्टिस गर्नुपर्छ बढी अब मैले एउटै क्वेसनमा जम्मै चिज आउने गरेर त्यो एकदम लेन्दी क्वेसन गरिदिएको जातमा यस्तै यस्तै खालको सोध्छ न्युमेरिकल है अब यो कुरा बुझियो भने यसरी गर्न सकियो भने तिमीहरूले यो आफै गर्न सक्छौ है तर यही क्वेसनलाई मैले एनालाइटिकल मेथडबाट पनि गरेको छु यो मैले ग्राफिकल सोलुसनबाट गरेको जाँचमा सकभर ग्राफिकल सोलुसनबाट गर्ने टाइम नभ्याउने कन्डिसन छ भने एनालाइटिकमा जाऊ होइन भने सकभर के गर त ग्राफिकल सोलुसनबाटै यसको चाहिँ के अन्त भन्दा न्युमेरिकल हल गर्ने कोसिस गर्ने है अब यो अलिकति लामो हुन्छ आत्तिनु हुँदैन नभ्याउने कन्डिसन छ भने एनालाइटिकल मेथडमा जाऊ फर्मुला युज गर्नेमा होइन म यसरी नै म भ्याउँछु भन्ने छ भने तिमीहरूले चाहिँ सकभर ग्राफिकल सोलुसनबाट गर्नु है this is far now same numerical problem can be used by using the analytical method. Okay, using the analytical method to calculate the sectional area. How can you calculate the sectional area of the fully filling and the partially filling cutting without considering the graphical solution? You can use by using the formula. You can find the area of the cutting, area of filling, or area of partial cutting, or area of partial filling. For the fully case, area of filling will be this formula is used as b square plus r square twice bd plus st square divided by r square minus s square. This formula is used for finding the fully area. Where in this equation, I have there is no the full width of the road. This small b is the half width of the road. If you remember this formula, sb square plus r square twice bd plus st square divided by r square minus s square. This is the formula for calculating the fully case area. Okay, fully case area. If depth is provided in filling, then area will be fully filling. And you have to put the slope of the area, slope of the filling, yes, and depth of the filling d. If this is the fully case of filling, then provide the slope of filling and provide the depth of filling. Okay. If this is the fully case of cutting, then provide the slope of side slope of cutting and provide the depth of cutting. If that is a fully case, okay, the same formula can be used. Only you can change the value of depth and the as for the respected cutting and the filling slope, filling cases, cases. Okay, and formula is same. Now for the partial case, if you multiply r times d and that value is less than the half width of the road, that is the small b, that value is less than small b, at that time you cannot use this the fully case area formula. Okay, you have to use this formula. This formula is half b plus minus rd whole square divided by r minus s, where d is respected depth provided, and S will be the respective slope, side slope of the cutting or filling. R is the cross slope that is calculated or that is provided for the partial case. If there is a d is equal to 0, that is calculated by using the mean harmonic slope, then at that time the R value will be Rm. Okay. If that is provided along the channels, then that value will be Rm value also same as the R value. So that this is in this formula there is plus minus. Okay, if the depth is provided for filling, but the case is partial. If the depth is provided for filling and the case is partial, then the sectional area of that filling will be high. So take the value of positive value for that finding the area of filling, and then take negative value for finding the area of cutting. If D is filling given, then the area of filling will be high. So put the value of take the positive sign for calculating area of filling, and take negative sign for calculating area of cutting. Okay, if you are provided with the central line depth as cutting depth, and the case is partial case, then area of cutting will be high. At that case, take the positive value for cutting area, and the negative value for the filling area. Okay, respectively you can do in this way. If D is equal to DF, take positive sign for calculation of the banking area. Okay, and take negative sign for calculation of cutting area. If D is equal to DC for the partial case, take positive sign for the calculation of cutting area and take negative sign for the calculation of filling area. If D is equal to 0, for the partial case, D is equal to 0, also the partial case, put the value of D here. The R into D will be 0. Okay, RD will be 0. So this equation reduces to half B square by R minus S. Okay, if D is equal to 0, then the formula for partial area calculation reduces to area partial is equal to half B square by R minus S. You must know these two formulas. You must know these two formula, and this formula third is automatically developed by putting the value of D is equal to 0 in this equation partial case, and the formula will reduce to half B square by R minus S automatically. Okay, now I am doing the same question using the formula analytical method. For the geometer challenge 50, 100, 114.06, 150, 200, 250, 271.74 and 300 meter. And these are the changes, and some changes are calculated according to the change of the section from cutting to filling or filling to cutting, and there may be in between the geometer changes. That change is calculated, and with respect to that change, the mean harmonic cross slope RM also calculated. Okay, in the previous example also we have already calculated that. Okay, after calculating, we know all the changes cross slope, and I keep this cross slope along the cross slope line. Okay, now depth of cut or fill is provided here. For the geometer challenge, the depth is 1.25. I have to mention here. The negative sign for cut. Negative sign for cut is mentioned here. Okay, I have already mentioned here negative sign for cut. Now 1.25, this is positive sign filling. 0.50 filling. 0.90 filling. 0.00, this is not positive, not negative. And to minus 2.3 is this is for cutting, and minus 1.3 is for cutting here. Okay, this is minus 1.3. This is minus 1.3 for cutting, minus 2.3 for cutting. Okay, this is marked here because cutting is 2, other is filling, and 0 change is 3. Okay, now for the first case, 10 into 1.25, this is 12.5 greater than half width of the road. Half width of the road is 5 meter. Okay, b small b is the half width of the road, b by 2, and this is 5 meter. And this is 12.5 is greater than 5 meter. So this is fully filling because depth is given as filling. This is fully, in the remark I have written as fully filling. Okay, this case is. So the area filling will be, use the fully filling area formula. Use the fully case area formula, SB square plus R square twice BD plus ST square, R square minus S square. I have provided the sectional area of filling as SB square plus R square twice BD plus ST square divided by R square minus S square. R square minus S square, R square minus, not D square, R square minus S. This formula is used here. Okay, this is the fully area. Fully area formula is written here. And the area, this is a fully case, so depth is filling depth, so area filling is here. Area filling will be, the value of S for filling is 1.5, 1.5 into B is 5 meter, 5 square, plus R is 10, 10 square, and 2 into 5 into D, twice BD, plus S is 1.5 and D is 1.25 square, divided by R square minus S square. You will get the area filling of 15.59 square meter here. By calculating, using the formula, the area filling is calculated as 15.59 square meter. But this is a fully case, so the area of cutting will be 0. Area of cutting will be 0. Okay, fully filling, so area filling area is here, cutting area is 0 automatically. Okay, now for the second case, 50 meter channel, 5 into 0.503 meter, which is less than small b 5 meter. This is the partial case. The area, the depth is given for the cutting or filling depth. Okay, depth is given for the filling depth. The area of the filling must be greater than the area of cutting. So take the positive value. Because this is partial case, we have to use the formula of this. Uh, uh, half b plus minus RD whole square divided by R minus F. This formula must be used, and the depth is given as the filling depth. So for the filling area, take positive value, and for the cutting area, take negative value. Okay. Now area filling will be partial case, so the area filling will be half b plus RD whole square divided by R minus F. Area of cutting will be half b minus RD whole square divided by R minus S. The S value for filling is 1.5 and S value for cutting is 1 here. And you can get the value of the area of filling and the area of cutting as 7.11 and 0.40 square meter respectively. Okay. Now for the challenge 100 meter, 0.90 into 7, 6.3, which is greater than 5 meter. See, this is also fully filling case. The same formula is used. SB square plus R square twice BD plus ST square divided by R square minus S square. If you use this formula, area of filling will be, put the value of D as 0.5090, R as 7, and the S as 1.5 in this formula of the fully filling formula. You will get the value of area of filling as 11.51 square meter. And the area of cutting is 0 because it is fully filling case. Okay, area of cutting is 0. Now for the challenge, challenge 114.06, this is the D is equal to 0 challenge. The depth is 0 here. The depth is 0 here. So this case is the partial case, having depth is equal to 0. For the partial case having depth is equal to 0, the formula reduces to half b square by R minus S. The formula reduces to half b square by R minus S. B plus minus RD whole square divided by R minus S. Half B plus minus RD whole square divided by R minus S. The RD value will be 0. So B plus minus RD square becomes the B square. Okay. And this equation reduces to this equation. And you can use this equation half B square by R minus S. You will get the value of 2.5 square meter for filling and 2.27 square meter for the cutting. Okay. using this formula, because they use the same formula, half B square by R minus S. S for the cutting is 1, S for the filling is 1.5. Only difference is that all other things remain same. Okay, you will get the value of the area of filling and cutting. In this way, for the chain is 150 meter, the 2.3, this depth is for the negative depth is here. This is for the cutting case. If you multiply 6 into 2.3, this is greater than the 5 meter. And this is case of the fully cutting, because depth is given as cutting depth. This is fully cutting, and use the same formula of the fully case, SB square plus R square plus BD plus SD square divided by R square minus S square. This area will be 0 for the filling here, because it is fully cutting case. So area of cutting will be S for cutting is 1, B square is 5, B is 5, SB square plus R is 6 square, twice BD, D is 2.3, D is 2.3 plus SD square divided by R square minus S square. You will get the cutting area of 29.81 square meter and the filling area of 0, because it is fully cutting case. Okay, in this way you can calculate all the areas of the respected rows, area of filling as well as area of cutting. Now mean area. Mean area is calculated for the first serial number and the second serial number. For the first case, there is no mean area of the single area. There is no mean. And for the second case, the area of filling and the area of cutting is also calculated here. And take the average of the area of filling as 15.59 plus 7.11 divided by 2. The area of filling average will be 11.35. Similarly, area of cutting average will be 0 plus 0.40 divided by 2. You will get the value of 0.20. The distance is 50 minus 0, 50. You can volume. You may put the volume in double row here and double column here. I have limited space, so that's why I am providing the volume red and the black one. Calculated volume as the red for the cutting and the black for the filling. Okay, so 0.20 into 50, it will be 10, and 11.35 into 50, it will be 567.50 cubic meters for cutting and filling respectively. Okay, you have to do by providing the double column here, cutting volume and the filling volume. Okay, respectively, you will get the and provide the data around the respected column. Okay, I have done in the single column by separating the volume by the colors. Okay, red color for the cutting volume and the black color for the filling volume in the same column. If you provide the negative sign for cut, then you can provide negative sign also. Otherwise, you may provide the double column for the respected cutting and filling here. Okay, in this way you can calculate the volume of cutting and filling. Okay, do for other changes using these both the two equation, two formulas for the fully case as well as the partial case. Okay, if depth is given for the partial case, if depth is given as the filling depth, then filling area will be bigger, and that's why take the positive sign and negative sign for cutting area. If the for the partial case, if the depth is given as cutting depth, then area of cutting will be bigger. So take positive sign for cutting and negative sign for filling. Okay, in this way you can use the partial case formula by yourself. Okay, do it by yourself. You will get the and add up all the cutting volume as well as the filling volume. You will get the total volume of 1819.01 cubic meter and 1906.16 cubic meter. These volumes are similar to the volume calculated in the by using the graphical solution. They are nearly equal. Okay, 1816.59, 1911.12. You can calculate here 1819.09 and 1906.69 respectively. You either use the formula method, or you can use the graphical solution. It is much better to use the graphical solution than the formula in the examination. If you don't have sufficient time, At that time, you can use the analytical method to solve the problem fastly or quickly. Okay, to solve the problem quickly, you have to use the analytical method. In case of not completing the question by using the graphical solution, it is better to use by analytical method in that case. Okay, hello. ल मैले आज तिमीहरूलाई यो 7:32 भइसक्यो। अब यो कति बजीसम्म हो? कति बजीसम्म हो यो क्लास? 7:30 बजीसम्म हो नि। 7:32 भइसक्यो, क्लासको टाइम सक्यो। अब मैले हिल रोड र प्लेन रोडको सकेँ है। अब एक्जाममा आएको पुराना क्वेसनहरू सल्भ गर, केही प्रब्लम छ भने सोध, म गरिदिन्छु। होइन भने यो हिल रोडको चाहिँ र प्लेन रोडको मैले कम्प्लिकेटेड चाहिँ क्वेसनहरू राखेर गरेको है। यो कम्प्लिकेटेड क्वेसनहरू राखेर गरेको हुनाले यति गरेपछि यो जान्यो भने जस्तो सुकै प्रब्लम पनि हल गर्न सकिन्छ। यु क्यान डु एनी टाइप अफ प्रब्लम इफ यु अन्डरस्ट्यान्ड दिस प्रब्लम, यु क्यान डु एनी टाइप अफ प्रब्लम एन्ड डु अदर प्रब्लम्स अफ द that is asked in the final examination questions of the old questions, do for that problems. If you get confused or if you don't understand to know to do the problem, then you may ask for that problem. Okay, this much for today. I think I have completed the author for the plain road and the hill road. Next time we will do for the author calculation for the canal work, and then after completing this we will go for the other problems related to the figure of the drawings to calculate the quantities of various items of TV digging, that may be kitchen or well foundation, or that may be power foundation, etc. We'll do in the next week after completing the canal ortho. Okay, this is the very important course content of this estimating and costing to find the quantity of ortho for the plain road, hill road, or the canal road. One or two questions is generally asked from this side. So this is the important one in terms of the final examination also. Now this much for today. This is your break time. I think I want to stop my classes. Now let me take your attendance. 34 students are present today. I have downloaded the file. Let me stop the recording also. Okay.